All right, welcome to this explainer. Today we are going on an absolute masterclass into one of the most powerful, yet honestly fundamentally misunderstood tools in modern product development. We're talking about fine-tuning AI models. Look, if you're a product manager who's just kind of tired of slapping a basic API wrapper on a generic model and calling it a day, you are in the exact right place. We're going to explore the complete theory and the actual execution of fine-tuning, giving you the precise knowledge you need to build deeply defensible, highly specialized AI products.
Okay, let's dive into this. $47,000. That is the staggering annual savings that a single, finely tuned small language model can generate compared to routing those exact same tasks through a massive, heavy-duty AI API like GPT-4. So, this isn't just about making your product a little bit better, it's about fundamentally altering your unit economics. To get us there, here's our roadmap for today. 1. What fine-tuning actually is. 2. RAG versus fine-tuning. 3. The economics of small models. 4. Technical theory. 5. The PM process. And finally, 6. Responsible AI and data.
Let's kick things off with Section 1, what fine-tuning actually is.
So fine-tuning is not just giving an AI a cleverly written prompt, and it's not just pointing it to an external document. It's the process of taking a pre-trained foundation model, one that already understands the broad patterns of human language, and training it further on your own highly curated examples. You are fundamentally and permanently changing the internal parameters, the literal neural weights of the model itself. For instance, if you're building an AI paralegal, you aren't just telling it to act like a lawyer. You're permanently reweighting its neural network so it natively understands complex contract law right out of the box.
I love this quote because it really hits the nail on the head. Think of a base model like a brilliant, freshly graduated college student. They know a whole lot about the world, but they don't know your specific business. Fine-tuning is that specialized onboarding process. Instead of trying to teach them the entire English language from scratch, you're just teaching them your specific legal clauses, your unique brand voice, or your distinct customer support workflows.
Moving right along to Section 2, RAG versus fine-tuning. This brings us to what is essentially the golden rule of AI architecture. You want to use Retrieval-Augmented Generation, or RAG, when you need dynamic, ever-changing facts. RAG fetches external data at runtime, like pulling today's live inventory levels or reading a newly updated HR policy. But you use fine-tuning when you need to change the model's fundamental behavior. If you need a very specific tone, a rigid output format, like pure JSON, or a specialized domain vocabulary baked right in so you don't have to explain it every single time, well, that's when you fine-tune.
Now, what's really interesting here are the trade-offs. Yes, fine-tuning has a much higher upfront setup cost. You have to gather a ton of data and spend compute power to actually train the model. But look at what you get in return for that investment. You get massive task consistency and significantly lower latency in production. Because the knowledge and the style are baked directly into the model's weights, it doesn't have to go retrieve documents or read massive, bulky prompts before it answers. It just instinctively knows how to do the task.
All right, Section 3, the economics of small models.
Let's look at the hard numbers drawn directly from real enterprise case studies. If you're running 50,000 monthly interactions through a massive general-purpose API like GPT-4 for a specific customer service task, you're burning roughly $54,000 a year. But if you take a highly targeted small language model and fine-tune it exclusively for that exact same customer service task, your annual cost literally plummets to under $10,000. And here is the real kicker. Not only do you slash your costs, but for narrow, specialized tasks, the small, fine-tuned model actually often outperforms the giant model. We're talking hitting 94% accuracy compared to the generic model's 78%. So it's cheaper, it's faster, and it's better.
Which leads us to Section 4, technical theory and challenges.
Now, as a product manager, you obviously don't need to write the code yourself, but understanding what's happening under the hood is absolutely vital for making cost-effective decisions with your engineering team. You're going to hear the term LoRA quite a bit. It stands for low-rank adaptation. See, in the past, fine-tuning meant updating billions of parameters, which cost an absolute fortune in server time. LoRA is basically a clever shortcut. It freezes the massive base model and only trains a tiny, highly specific subset of new parameters. This means you can fine-tune a model on a single commercial GPU in a matter of hours rather than weeks. Add in QLoRA, which quantizes or compresses the memory footprint all the way down to a 4-bit format, meaning you don't need $1 million supercomputer. It drastically reduces your infrastructure costs while maintaining incredibly high performance.
But look, fine-tuning isn't magic, right? It comes with some major pitfalls. The absolute biggest one is called catastrophic forgetting. This happens when you train your AI on a new data set and it just suddenly forgets all the really useful general information it learned during its original pre-training. It's kind of like teaching a model a cool new trick, only to realize it basically gave itself a neural lobotomy and completely forgot how to speak English.
And honestly, this is exactly where the cutting edge of AI research is focused right now. While LoRA is incredibly cheap, studies show it still really struggles with catastrophic forgetting when you try to sequentially teach a model multiple new tasks over time. So researchers are developing newer techniques, like FIP, or functionally invariant paths. FIP basically maps out the mathematical landscape of the model's brain to ensure it retains its performance on those older tasks, even as your business needs evolve and you start teaching it new ones. Knowing these technical limitations helps you plan your product roadmap way more realistically.
All right, moving to Section 5, the PM fine-tuning process.
First and foremost, you have to remember that fine-tuning is a team sport. As the PM, your main job is to bridge the gap. You've got machine learning engineers writing the training scripts, data scientists evaluating the models, and subject matter experts who actually know the gritty details of the business domain. You are essentially the conductor, making sure the technical execution perfectly aligns with the actual business value.
So the actual life cycle looks like this. Step 1 is ruthlessly defining your objective. Are you matching a specific brand tone, formatting messy medical notes into structured data? You have to define that hyper-specific use case before you ever even touch an open-source model like Llama 3 or Mistral. Then you select your base model, prepare your training data, let the engineers run the training configuration, and finally, you evaluate and iterate.
I really want to hyper-focus on step 3 here, preparing data. In fine-tuning, the golden rule is garbage in, garbage out. If you feed the model bad examples, it will permanently learn bad behavior. You need at least 1,000 high-quality, perfectly formatted examples. And highly effective teams use techniques like chain-of-thought prompting in their data sets. That's where you provide examples that actively show the model how to reason step by step to reach an answer, rather than just handing it the final answer. Doing this drastically improves the model's complex problem-solving abilities. Always ensure you have rigorous human-in-the-loop quality assurance on your data before the training even begins.
Finally, Section 6, Responsible AI and Data. By fine-tuning on your own data, you are actively taking ownership of the model's outputs. You must rigorously test against specific risk vectors to mitigate enterprise liability. If your training data has bias, well, the model is going to naturally amplify it. And because models can inadvertently memorize their training data, you have to ensure absolutely no personally identifiable information, no PII, slips into your dataset, or the model might actually leak it to a user down the line. You also have to navigate copyright infringement and put hard guardrails in place to catch factual inaccuracies. As the PM, you have to build robust evaluation pipelines to automatically test for these exact enterprise risks.
Which leaves us with this final, really vital question for your product roadmap. Are you content just renting a generic AI that knows a little bit about everything but costs an absolute fortune? Or are you ready to leverage fine-tuning to build a highly specialized, deeply integrated, and incredibly cost-effective AI employee that is completely unique to your business? The theory is clear, the economics are undeniable, and now you have the playbook to execute. Thank you so much for joining this explainer, and honestly, I cannot wait to see what you build.